Hello guys and welcome to mathematics class. And of course in this class we're going to be looking at indices. Mathematics, and we're going to be looking at indices. So from the word indices means what? Index. It means what? Exponent. It means what? Power. So this is what index, this is what indices what denotes. It denotes what? Exponent, it denotes power, it can be called index, right? So do not forget that this tutorial is brought to you by O3 Schools, JAMB application. If you don't have this app on your phone, you are only doing yourself. And if you have it and you have not activated it, you are doing yourself more harm, right? So there are a lot of testimonies from last year, people who use this app, lots of testimony. People are in school already, which is the aim. The first step to going to school or to getting admission into any school is having a good JAMB score. This is what O3 School JAMB app will enable you to achieve. It has all past questions. It has everything that you need to succeed. It has a question search feature. It has mock exam that you can set for yourself. There's a challenge that you participate in every week to test how prepared you are for the exam, and lots of other wonderful things on the app. So if you have not activated it, please download it from Play Store. Go to Play Store, then click on activate. The activation of the app just costs 2,500 naira only. This is a small token that you are paying to say thank you for creating such a wonderful app. And if, of course, if you have downloaded yours, of course, you are going to join me in this class and we're going to use it together to learn. Let's head over to what we have on the board. So indices, we say indices means what? Index, it means what? Power, it means exponent. This topic is very crucial, it's very important. You need to understand this topic because for those of you who are doing physics, doing chemistry, you may encounter them in your calculations. So it will help you a lot. It will help you a lot to boycott some things. All right, so let's go. So let's see, indices has what? Indices has some laws. It is these laws that propel us, that guide us on how we should solve what questions that come from indices. And of course, the laws are as follows. So number one, we have a law like this, that x raised to the power a times x raised to the power b is equals to, if you have what the same base but and they have powers, they are multiplying each other, you are going to what? Take one of the base and then you add the powers a plus what? B. Get it? So for example, if you have 2 raised to the power 3 times 2 raised to the power 4, so you can, it's same thing as saying what? 2, you pick one of the base 2, then 3 plus 4, which is equals to what now? 2 raised to the power 7. So this is a simple explanation of what? Of what that first law means. All right. So of course, if they are not multiplying each other? What if they are dividing each other? So if you have two, if you have x raised to the power a divided by x raised to the power b, the same thing as saying that what? X raised to the power what? A minus what? B. So for example, if I have something like this, 2 raised to the power 4 divided by 2 raised to the power what? 3. It's same thing as saying 2 raised to the power 4. Sorry, 2 raised to the power 4 divided by 2 raised to the power what? 3. This is 2 raised to the power what? 4 minus what? 3. Because of 2 raised to the power what? 1, which is also the same thing as what? As 2. It's very easy to understand, right? So the first law, x to the power a times x to the power b gives you x to the power 8, a plus b. So the second one, x raised to the power a divided by x raised to the power b gives you x raised to the power a minus b. So this is what the simple what law, the first two simple laws that guides what our indices. All right, now there's another law. So let's go to another law, number 3. What if you have something like x raised to the power minus 1? If I have something like x raised to the power minus 1, it means 1 over x. X raised to the power minus 1 means what? 1 over x. That means if you have something like this, 2 raised to the power minus 2 is same thing as what? Or let me just say 2 raised to the power minus 1 is same thing as what? 1 over what? 2. It means the inverse of that, of whatever thing we're discussing. So another simple, a further explanation of this, we may call it the fourth law. So let me just make it clearer and easy for you. So if I have x raised to the power minus a, for example, it means what? 1 over, this negative sign is the over, right? It's 1 over, right? Then I got to have x raised to the power what? A. You bring x to the power a down. So now, number 5, if I have x raised to the power 0 is what? It's equal to 1. Anything raised to the power of 0, anything raised to the power of 0, whether it's 350 billion, million, trillion, quintillion, if it is raised to the power of 0, it is what? It will give you 1. So that's why that holds. This law of indices, it holds that anything raised to the power of 0 is 1. So let's go to more complex ones. If you have x raised to the power a over b, x is raised to the power of a over b, what you simply do, you take what? Root of what? Of b. B will be the root, or then x all raised to the power what? A. I'm going to explain this one. This one may be confusing a bit, right? So if you have x raised to the power a over b, the same thing as what? Putting x in a square root box, then the denominator of the fraction that it is raised to becomes the root. While what? A is what is raised. So for example, if you have something like this, 4 raised to the power 2 over 3, right? The same thing as saying the third root, the base, the third root of what? Of 4, all raised to the power of 2. It's as simple as ABC. Very simple as ABC. So let's see another one. Let's say you have something that's x raised to the power minus a over b. This one is raised to a positive number, but this one is raised to a negative number. This one is something that say 1 over what? X raised to the power what? A over what? B. And then the same thing as what? 1 over, we can continue from here, the square root, or sorry, the bit root of what? Of x all raised to the power what? All raised to the power A. So these are laws guiding indices. I don't think there's anyone I'm missing out. So you just need to understand the laws, understand how the laws operate, so that whenever you encounter them in any calculation, it becomes very easy for you to be able to apply. So let's go over them again, because after now we are going to start solving questions only questions. So now if I have what? X raised to the power a times x raised to the power b, they're having the same base, but whether the powers are the same or not is not our problem. Just take one of the base, then add their power, provided here is multiplication. But if it is division, then take one of the base, subtract their what? Their powers, like the example we gave here. Then of course, if you have x raised to the power minus 1, it's same thing as what? The inverse. Anything raised to the power minus 1 means the inverse of that thing. If they say what? 50 raised to the power minus 1, same thing as what? 1 over what? 1 over 50. Even 1 million raised to the power minus 1 is equal to 1 over what? 1 million. So like that, like that, like that. So that is the law for you for this third one. So the same thing goes that what? X raised to the power minus a. X raised to the power minus a. This minus is 1 over. So that 1 over what? X raised to the power what? A. Now, anything raised to the power 0 is what? Is 1. That is it here. So if you have something like this, 2 raised to the power 0, for example, is equal to what? 1. Then 50 raised to the power 0 is what? Is 1. Anything at all that is raised to the power of 0 will give you 1. Now, likewise, let's move. If you have x raised to the power a over b, that means x, that means a number is raised to what? A fractional power. A fractional power. So what you do, you take what? The denominator of the fraction becomes the root, while what? The a is raised. That means the numerator is raised, but the denominator becomes the root. So that's why I have was square root of what? X, bit root of x, sorry, raised to power what? A. That is, if we have an example like this, 4 raised to power 2 over 3, we take the third root, the denominator, the third root of what? Of 4, then we raise everything to what? To 2. Likewise, this is just an extension of this law. If you have x raised to the power minus a over b, same thing as what? From our law here, anything raised to the power minus something, you invert it. So 1 over what? X raised to the power a over b, which will further what? Give us what? That solution. So the first thing you should do, learn to write these rules down without looking at the board. So that's your first assignment. Learn to write these rules down from your head without looking at the board. That's your first assignment. So please, can pause the video, then try to learn it first before you start jumping into answering questions with me. All right, now let's start with questions. It's question time. So I'm going to open our O3 School JAMB app, right, which is fundamentally the best JAMB CBT practice available online and everywhere for us to what, to look for questions and what, and start what, attacking them. So now let's see the question. It's a 1988 question. A 1988 question, question number 8, a past JAMB question. All right, so they said evaluate. You have 8 raised to power 1 over 3 times 5 raised to power 2 over 3 all over 10 raised to power 2 over 3. So you can see these are all having what, fractional what, powers. They are all having fractional powers. So now what do you do whenever you see something like this, right? So you do this. Now 8 raised to power 1 over 3, our options A is 2 over 3. B is what? 5 over 3. Our C is third root of 5. D is third root of 2. All right, so let's see which answer we are going to get. All right, now let's go. Now, what does this mean? 8. Like I've told you before, when we're doing number basis, I told you to learn what the powers of what, 2, the powers of 3, the powers of 4, the powers of 5. Now, the knowledge of that will help you to solve this question clearly without wasting time. So we know that what, 2 raised to power what, 2 raised to power 3 is the same thing as what, 8, because 2 times 2 is 4, 4 times 2 is 8. So I'm going to have 2 raised to power 3 times what, 1 over 3, yeah, right, for this. Then times 5 raised to power 2 over 3, right? All right, all over now 10 raised to power 2 over 3. 2 times 5 is what? Is 10. So you can simply say what? 2 times 5 all raised to power what? 2 over 3. Why is it all raised to power 2 over 3? Because what? This power is affecting the whole 10. So it will be affecting this and affecting this likewise. So this will give us what now? 3 here 1, 3 here 1. So I'm going to have what is left? 1 times 1 over 1 is what? Is still 1. So I'm going to have 2, then times what? 5 raised to power 2 over 3 all over. You know this power is affecting everything here. So that means here now, if you want to open this bracket back again, I'm going to have 2 first. The first 2 raised to power what? 2 over 3. Then times what? Then 5 raised to power what? 2 over 3. You get it, right? So we just broke down this 10 raised to power 2 over 3 into 2 times 5 raised to power 2 over 3. So now 5 raised to power 2 over 3 can cancel 5 raised to power 2 over 3, right? Or if you don't want to cancel it, if you don't want to cancel it, so that you understand it perfectly, you understand what is happening here perfectly using one of the laws of indices. 5 raised to power 2 over 3, 5 raised to power 2 over 3. You're not going to have what now? Now, this is, can separate them, 2 raised to power 1 over what? 2 raised to power 2 over 3, then times 5 raised to power 2 over 3 all over 5 raised to power 2 over 3. Now, remember what I've told you initially, if you are dividing what indices, if there's a division sign, what you do, what you subtract that power. So there's a division sign here, that means you're going to have 2 raised to power what? 1, then minus what? What's the power here? 2 over 3, right? Isn't it? Then times what? 5 raised to power what? 2 over 3. 5 raised to power 2 over 3, then minus what? Minus 2 over 3. 2 over 3 will cancel 2 over 3, right? 2 over 3 minus 2 over 3 is 0. Now, 1 minus 2 over 3. Do your LCM. 1 minus 2 over 3. 1 over 1. I'm doing this first example because I'm treating you as Omomo. From the second one, we're going to tear with speed. All right, so now let's continue. So I go to LCM is what? Is 3. 3 divided by 3 is what? 3 divided by 1 is what? 3. 3 times 1 is what? Is 3. So 3 minus 3 divided by 3 is what? 1. 1 times 2 is 2. I'm going to have 1 over 3. So I'm going to have what now? Let's take it up here. So I'm going to have 2 raised to power what? 1 over 3. Then times what? 5 raised to power what? 0. Anything raised to power 0 is 1. So of course, this becomes what? 2 whole number and 2 raised to power what? 1 over 3 as our answer. Now, is 2 raised to power 1 over 3 in the options? It's not there. Our answer is what? 2 raised to power what? 1 over 3, but it is not in the option. Now, from indices, can we simplify this further? That is the next thing you ask yourself. Yes, we can simplify this further. And this simply means that what? The third root of what? Of 3, of what? Of 2, all this power what? 1, which same time what? Third root of what? Of 2, which is option D. You see how very simple it is? It's very, very simple. So your laws of indices are crucial for you to understand whatever has been done here. If you do not understand your laws of indices, you may be biting your hand or biting your tongue, right? To understand the laws of indices, then you can start to tackle questions. Let's take another example, and then let's move with speed, of course, like I have promised. Let's move with speed. All right, so let's take another example. This is question 2. Question 2 is 1989 question 5. So they say simplify. By giving what? Third root of 64. R raised to power minus 6. This is R, right? Then everything raised to power 1 over 2, right? So you have to understand where these powers are. This third root is here, 64 is here, R raised to power minus 6. Then this 1 over 2 is here, right? So now we already know what third root means. The third root means what? What does third root mean? That means we can break this out. We can break this down, right? There's a square. There's a square root here, but apart from that square root, there's a what? Power of 1 over 2 here, isn't it? So let us start from inside, then we'll come outside. Or we cannot, because going from we can also decide to come from what? To start from outside to inside, but it's easier. Let's start from inside. So from inside, because we can work on it, our options, we're giving options. Options A is what? Is R over 2. B is what? Is 2R. C is 1 over 2R. D is what? 2 over R. So what do we do? Let's start from inside. Now, the power of 1 over 2 here means what? Square root, right? So we can break this down into what? Let's put this down into 64 raised to power 1 over 2, because this 1 over 2 is affecting these two, 64 and R. Then times what? R raised to power minus 6 times what? 1 over 2, right? It's inside the third root. Now, what other thing can we do, right? We also know that what? If okay, let's solve this and get what? A simplified version. 2 here 1, 2 here 3, right? So I have R raised to power minus 3 inside here. Then here it means what? The square root of 64. Square root of what? 64 times what? R raised to power minus 3 is what is left, right? Everything is inside this third root. Are you together? All right. So I want to have third root of what? What is the square root of 64? 8. Then times what? R raised to power minus 3. Now we're having third root. Third root means what? Power of what? Power of 1 over 3. That's what third root means. So that means you can simply break this to be equal to what? X root over what? 1 over 3. Then times what? R raised to power minus 3 times 1 over 3. So that's 3 will cancel what? 3, right? Leaving what? Minus 1 there, of course. Then what is the third root of 8? The third root of 8. Third root of 8 is what? Is equal to what? Is 2. Because 2 raised to power 3 is what? Is 8. So I'm going to have 2. I'm going to have 2 times what now? Times R raised to power minus 1. Then we know that anything raised to power minus 1, if I have R raised to power minus 1 for our law of indices, same thing as what? 1 over R. So this will give us 2 times 1 over R, which is equal to what? 2 over R, right? So that will be our option D. So you can see how very easy these things are. They are very, very easy. If there's anyone you do not understand, please take this video back, and then look at it carefully again and do it yourself. Make sure you do every question we do here by yourself. Now, there's another question here. This is a 1990 question. I doubt if JAMB will want to give you this kind of question, because these are for older years, right? In those years, JAMB had a lot of time. Like people had a lot of time to write the JAMB exam, like almost close to 4 hours, 3 hours, 30 minutes to 4 hours to write the exam. Not now that it's like 2 hours, right? So, but it's not still a question, it's still a question that you can solve under 1 minute if you can reason very fast. Now let's see the question. The 1990 question says simplify. We're given this long square root 160 r square plus you have another square root inside 71 r raised to the power 4, right? Plus, you see, this square root is inside here, right? This square root is inside here, then plus there's another square root here, 100 r raised to the power what? Raised to the power 8. All right, we're given options. Okay, so there are options. Option A is 9r square. Option B is 12 3r root 3r. C is 13r and D is root 13r. Root 13r. All right, so now merely looking at this question, you if you do not know what you are doing, you may be destabilized. You say, but it shouldn't be like that, of course. It's very, very easy. So what do you do whenever I see a question like this? The first thing you do is start attacking it from inside out. So that means you 12 or treat this. If you treat this 100 r raised to the power 8, if you treat it, I'm going to have what? Square root, right? It's in square root. Square root means power of 1 over 2, isn't it? So this means 100 square root of what? Of 100, then times what? R raised to the power 8 times what? 1 over 2. I don't know if you understand. Because this square root means 1 over 2, right? It also means that what? 100 r raised to the power 8 all raised by what? 1 over 2. This is what it means, right? That means it will affect both this and this. You get? So we're going to have square root of what? Of 100 times what? R raised by 8 times what? 1 over 2. So 2 here, 1, 2 here will be 4. Square root of 100 is what? Is 10. We're going to have 10. What is left here? 4 times 1 is 4. 10 r raised by what? 4. So we have the first inner one. So the inner one has been dealt with. What we now do next is to now solve this one. We have solved this one. This one here has been solved. So we need to now solve this one first. So now I'm going to have what now? Let's bring them together. I'm going to have square root of 71 r raised to the power 4 plus what did you get here? 10 r raised to the power 4. 10 r raised to the power 4. So if you add them together, that will give you what now? 81 r raised to the power 4 square root, isn't it? So it is still there. The square is still there. So let's deal with this. Let's get a value. Square what this is, so this is something as what? First of all, something as square root of 81 times r raised to the power 4 times 1 over 2. 2 here 1, 2 here 2. What is the square root of 81? 9. 9. What is left here? 2 times 1 is 2. 9r square is left here. So we have 9r square left here. By the time we have simplified everything here to be 9r square. So now let's now bring our solution from here to this place to add. So we now have your square root again. 160r square plus what now? What's here? 9r square. So 160r square plus 9r square is what? 169r square, isn't it? So now we have seen that this is 169r square. Now it is also in a square root. So we'll do the same thing. Square root of what? 169, then times r square times 1 over 2. 2 here 1, 2 here 1. Right? So what is square root of 169? That is what? 13r. What is left here is only r, right? 1 times 1 is 1. Divided by 1 is 1. So 13r is what is left there. And that will give you your option C. Your option C. Now that we have known, we have solved two questions. I mean 3 questions. This will be the 3rd question we are solving in this topic. And of course, you can see how easy it is. So whenever you get a question like this, what you need to do is to start from inside, then solve outside. Of course, if you do that, you see that what is becoming very, very easy. Some of you don't get scared whenever you see mathematics. Do not be scared. Mathematics is very, very enjoyable and very easy. Do not be scared when you see math questions. So now let's go to the next one. Let's go to the next one. haven't gotten that clearly, let's go to the next one. So the next one we are having here is, what is the product? So what is the product? The product of 27 over 5, 3 raised to the power minus 3, 3 raised to the power minus 3, and 1 over 5, all raised to the power minus 1, right? So they just want to test your knowledge of indices here. So A, they say the 5, B, they say it's 3, C, they say it's 1, D is what? 1 over 25. So these are what? The options. All right, now the product. Product of 27 over 5, then that is times what now? 3 raised to the power minus 3, then times 1 over 5 raised to the power minus 1. Product means what? Multiplication. Product simply means multiplication. So they say multiply everything together. So let's apply our laws of indices. So this is what? 27 over 5, then times, remember our law of indices, that's what? X raised to the power minus 1 is what? 1 over x, isn't it? So this means 1 over what? 3 raised to the power 3. Then times what? Remember when we say raised to the power minus 1 means to invert it. So if I'm inverting this one, that means 5 is coming up, then 1 is coming down, isn't it? So this is what? 3 raised to the power 3 here 1, 3 raised to the power 3 will cancel 27. 3 raised to the power 3 is 27. Look at it. 3 times 3 times 3 is 27. 3 times 3, 9. 9 times 3 is 27. So they'll cancel out. 5 will cancel 5. Our answer will become what? 1. You can see very easy. Very easy. This question is not worth for 30 seconds. I'm not sure we solved it even within that time range, plus even writing the question on the board. So you just need to understand the laws, and then you are good to go. All right, let's take another question. This is a 1995 question, number 6. So they said evaluate 81 raised to the power 3 over 4 minus 27 raised to the power 1 over 3 all over 3 times 2 raised to the power 3, right? Okay, so let's go. This is very, very easy, isn't it? It is very, very easy still. So what do we do? 81 is same thing as what? 3 raised to the power 4. If you remember, 3 times 3 times 3 times 3. 3 4 times. 3 times 3 is 9. 9 times 3, 27. 27 times 3 is 81. So I'm going to have 3 raised to the power 4 times 3 over 4. Isn't it? Then minus what? This 27 is something as what? 3 raised to the power what? 3 times 3 times 3 is 27. So that is 3 raised to the power 3. 3 raised to the power 3 times 1 over 3 all over 3 times what? 2 raised to the power 3. All right, let's go. 4 here, 1, 4 here, 1, 3 here, 1, 3 here, 1. So what is left? Well, left here is what? It's what? 3 raised to the power 3. 3 raised to the power 3 minus, what is left here? 3 raised to the power what? 3 raised to the power 1. That's what is left. All over what now? 3 times what? 2 raised to the power 3. Isn't it? All right, so what's 3 raised to the power 3? Yeah, it's 27. 27 minus 3 raised to the power 1 is what? Is 3 all over 3 times 24. 2 raised to the power 3. 2 raised to the power 3 is what? Is 8. Sorry. 2 raised to the power 3 is what? Is 8. 2 raised to the power 3 is times 2 times 2 times 2, which is 8, right? So what's left here? 27 minus 3 is what? Is 24. 3 times 8 is what? Is 24. 24 divided by 4 is what? Is 1. So our answer is what? Is simply 1. Everything reduced there to what? To 1. So it's that simple. All right, so let's quickly move on to the next one. They said without using tables, evaluate, we're told to evaluate 343 raised to the power 1 over 3 times 0.14 raised to the power minus 1 times 25 raised to the power minus 1 over 2. Without using table, evaluate this. So it's as simple as ABC. Also, let's apply our laws of indices. 343 is same thing as what? 7 raised to the power 3. Because 7 times 7 is 49. 49 times 7 is 343. You get it? So you must know these things from your number base. We have done lots of them before. So from here now, I'm going to have now 7 raised by 3 times 1 over 3, isn't it? And times we have 0.14. 0.14 in fraction is something as what? 14 over what? 100, because you shift your decimal place how many times? Twice. So 14 over 100. So it's something as what now? 14 over 100 all raised by what? Minus 1. Then times this one is something as what? 1 over what? 25 raised by what? 1 over 2. Abi, you remember? So I shouldn't be explaining that again. So 3 here, 1, 3 here, 1. So I'm going to have 7 raised by 1 or 7, then times. Since we're having minus 1 here, since it's raised to the power of minus 1, that means we have to invert this fraction. So I'm going to have 100 over what? Over 14. Then times what now? Yeah, same thing as what? 1 over what? Square root of what? Of 25. Mind you, whenever you are writing square root, if it is square root, if it is 2, you don't write it. You don't write it. This thing naturally means what? Root of what? Of 2. So you don't write 2 there, right? So that's just a point to note. So let's get over that. So I got our 7 over 1 times 100 over 14 times 1 over what is square root of 25? 5. 7 here 1, 7 here 2. 5 here 1, 5 here what? 20. 2 here 1, 2 here 10. So our answer will be equals to 10. It's very, very easy. It's in the option there. So 2002 question 2. All right. So we have seen lots of these questions. What is left? Okay, we have another question here from 2001. 2001 question 2. Let's solve as many questions as possible to keep us grounded so that we can be grounded in the topic. So this is a 2002 question, 2001 question, 2001 question, question 2. So it says simplify. Simplify. We're giving, I think I've done something similar to this before. 64a raised to power 3. But this time everything is raised to power what? Minus 1. Everything is raised to power minus 1. So of course, what does this mean? If you have everything raised to power minus 1, what does it mean? This means same thing as what? 1 over what now? Third root of what? 64 a raised to power 3. You get? So this minus has been taken away with what? With this one division sign. So now what do we do next? We simplify what's under. So I'm going to have 1 over what? Third root of what? 64. Then times what? Third root, that is a raised to power 3 times 1 over 3. Remember, right? Because here, breaking this down means 64 raised to power what? 1 over 3 times a raised to power 3 times 1 over 3. This is what it means. Third root. So now, 3 will cancel 3. Then what is the third root of 64? It will be 4. So because 4 times 4 times 4 is what? Is 64. So I'm going to have 1 over what? 4. And then what will be left? 3. 3 has cancelled 3. That is 1 times 1 is what? Is 1. 1 over what? 4a. It's very easy. Within 2 steps, we have gotten our answer. So know the laws of indices rather. We are going to get to logarithm in our next class. So let's do some more questions. All right, so this is 2006 question 25. 2006 question 25. This is from the O3 School JAMB app again. So let's go. So I'm going to have 25 raised to power 1 over 2 times 27 raised to power 1 over 3 plus 121 raised to power minus 1 over 2 and 625 raised to power minus 1 over 4. So this is what the question before us. Alright, so now what do? Once you see something like this, we're not supposed to panic. We just want to test our knowledge of what? Of powers. So it's as simple as ABC. So because we have already explained all the explanation, this one I'm not going to be delaying. Let's hit the road. Of course, I'm going to have square root of what? 25, right? Isn't it? Because we're having what? This. Then times third root of what? Of 27. Let me check with this. minus. Okay, there's minus here because without that minus, now our answer will be wrong. So I'm going to have 1 over, isn't it? This. Then times, let me clean this so that we can have it in one line and not get confused. So this same thing, 1 over what? Square root of what? 25. Then times third root of 27. Then is it okay? Then plus what now? 1 over square root of what? 121. Then times 1 over fourth root of 625. What is the square root of 25? Is what? 1 over 5. Then times what is the third root of 27? Is 3. Times 3 over 1. Then plus what is the square root of 121? 11. Then times what is the fourth root of 625? Is what? Is 5. So 5 times 5 times 5 times 5 is 625. So 5 raised to the power 4. Of course, that means what? 1 over what? 1 over 5. Now let's do this. 3 times 1 is what? 3 over 5. Then plus 1 times 1 is 1. 11 times 5 is what? 55. Give your LCM, you have 55. 55 divided by 5 is 11. 11 times 3 is 33. Then plus 55 divided by 5 is 1. 1 times 1 is what? Is 1. So 33 plus 1 is what? 34 over 55. A very simple question. A very wonderful approach with a nice, simple answer. So now that is that for that question. Very easy. Take it back if you do not understand, because there's nothing much for me to explain there. So this from the old school JAMB again, 2000, number 9. We're given 3 into bracket 2 raised to the power n plus 1, right? Then minus 4 into bracket 2 raised to the power n minus 1 all over 2 raised to the power n plus 1 minus 2 raised to the power n. All right, so medicine this question, some people will start crying. Oh my God, where did they see this question from again? It is very easy. Calm down, look at it again and see what you can do. Now, from here, we know that what? 4 is same thing as what? 2 raised to the power 2. That will help us. So that we have 2, 2, 2, 2, 2, 2, 2, 2. You get? Now, let's do that. If we do that, I'm going to have 3 into bracket 2 raised to the power n plus 1 minus 2 raised to the power 2 into bracket 2 raised to the power n minus 1, right? All over 2 raised to the power n plus 1 minus what? 2 raised to the power n. Now, remember from laws of indices, that's what? 2 raised to the power 2 times what? 2 raised to the power n minus 1. That is this and this. We can simplify it to be equal to what now? 2. Take one of the base, then 2 plus n minus 1. 2 minus 1 is what? Is 1. Then n. So what is left here is what? 2 raised to the power n plus 1. So that means everything here, this and this, will give us this 2 raised to the power what? N plus 1. Alright, so we'll bring that into the show. Let's bring that into the show now. So we're bringing that into the show, and I'm going to have what now? So because of what now? 3 raised to the power what? 2 n plus 1 minus what? 2 raised to the power what? N plus 1, isn't it? Right? Then all over 2 raised to the power n plus 1 minus what? 2 raised to the power n. Now, there's n plus 1 here, there's n plus 1 here. We can simply factorize. So I'm going to have 3 minus 1, because this is 3. This is 1 times, this is the same thing as what? 1 into bracket 2 raised to the power n plus 1. So 3 minus 1, you now take 2 raised to the power n plus 1. Factorize it out all over this 2 raised to the power n plus 1. 2 raised to the power n plus 1 can be broken down to be what? 2 raised to the power n times what? 2 raised to the power 1. So that if you want to have this back, it's just to add the powers again, isn't it? Then minus what? 2 raised to the power n. All right, right there. So 3 minus 1. Let's come here now. 3 minus 1 is same thing as what? 2 into bracket 2 raised to the power n plus 1 all over what? This is what? 2 raised to the power. We can now simplify. Can you simplify 2 raised to the power n out of here? Of course, we can simplify. There's 2 raised to the power n here, there's 2 raised to the power n here. So we can simply bring what? 2 minus 1 into bracket what? 2 raised to power n. 2, 2, 2, this 2 here, then minus what? 1n. There's 1 times what? 2 raised to power n. So this same thing as what? 1 into 2 raised to power n. That's how we factorize this out. So what is left now is what? 2 raised to power what now? 2n plus 1 all over 2 minus 1 is what? Is 1. 2 raised to power 2 raised to power n. So that we can break this one down now to how we broke this one down. Where did we do that? How we did this from here to here. So we can break this one down to what now? Let's bring it up here because of visuals. So I'm going to have 2 times what? 2 raised to power n times what? 2 raised to power 1 all over now 2 raised to power n. So 2 raised to power n will cancel 2 raised to power n. 2 times 2 is 4. So we have gotten our simple answer as what? As 4. So those are very, very easy questions. Those are very, very easy questions. Now let's look at the last part of this class, which is indices involving fractions. Sometimes we'll be solving what? Indices question, and then it will lead us into what? Equations. So in that case, there is a rule that applies. If the bases are equal, you equate the powers, right? It is very, very handy in the next part of this lesson. All right, let's see an example on that so that we can call it a day on this topic, because I think we have taken a lot of time. All right, now indices involving equations. Let's see. It's a 2004 question number 46. They say given that third root of 4 raised to power 2 x is equals to 16. They say find x. A is 4, B is 6, C is 3, D is 2. So it's that simple. So now we're given this question. So likewise, we also use our laws of indices that we have learned. So this also means that what? This is third root. So it means 4 raised to power 2x times what? 1 over 3, isn't it? Then it's equals to what? 16. Can we express 16 in the powers of 4? Yes. So we're going to have 4 raised to power 2x times 1 over 3 is equals to what? 4 raised to power 2, isn't it? Because 4 times 4 is 16. So because they are having equal bases, so you say equal bases gives us the right to equate the powers. Equate powers. Are you together? So now, here will give us what now? Because they are equal bases, we equate the powers and cancel out the bases. So I'm going to have 2x times 1 over 3 is equals to what now? 2. Right? So 2x times 1 is what? 2x over 3 is equals to what? 2. Because multiply 3 times 2 is 6. So I'm going to have that 2x is equals to 6. So divide both sides by 2, x will be equals to what? 6 over 2, which is equals to 3. It is that simple. It is very, very, very simple. Nothing more, nothing less. So whenever you are in this condition and you have the same basis, simply equate the powers and you will get what? The unknown. All right, let's go to another question quickly. That was very easy to solve. Very easy to solve. All right, now this is a 1979 question number 49. 1979 question number 49. So they said if 3 raised to power x is equals to third root of 9, they say find x. So this one is also very, very easy. So you have this 3 raised to power x is equals to what now? Third root of what? 9. So for our indices, 3 raised to power x square root means what? Power of 1 over 2. So that means I'm going to have 3 raised to power x times 1 over 2 is equals to what now? 9. This is third root bar 1 over what? 3. Altogether, this is 9 raised to power 1 over 3. Third root means 1 over 3. Square root means 1 over 2. So can we express 9 in power of 3? Yes. So I'm going to have 3 raised to power what? X times 1 is x over 2 is equal to what? 3 raised to power 2 times 1 over 3. Altogether, 9 is what? 3 times 3 is what? Is 9. So 3 raised to power 2 times 1 over 3. So because they are the same basis, equal basis, then you what? You equate powers. So if you equate powers, you to have x over 2 is equal to what? 2 over what? 3. 2 times 1 is 2. 3 times 1 is what? Is 3. So cross multiply. So that what your 2 times 2 is what? 3 times x is what? 3x. 3 times x is 3x is equal to what? 4. That means your x is what? Divide both sides by what? By 3 over 3, 4 over 3. X is equal to what? 4 over 3. It's very, very, very easy to answer. All right, let's see one last question. One last question. I'll call it a day on this topic. It's a 1978 question number 38. 1978 question number 38. All right. So as I said, if 25 raised to power x minus 1 is equals to 64 5 over 2 all raised to power what? 6. What is the value of x? Now we are given something like this, and we're given options. A is 7, B is what? Is 4, C is 32, D is 64, E is 5. All right, so we already know what we can express 5 in what? In power, 25 in powers of 5, isn't it? So 25 is what? 5 raised to the power what? 2. Then into this power is already here, x minus 1, isn't it? Then it's equals to what about 64? So okay, well, we can express 64 in the powers of what? Of 2. So 2 raised to the power what? 6 is 64. Look at it. 2 times 2 times 2 times 2 times 2 times 2. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 2, 32. 32 times 2, 64. So 2 raised to the power 6. Then into bracket. This power is affecting this 5 over 2. So it's simply absorb 5 over 6. All over what? 2 over 6. That means that what? This 2 over 6 can cancel this 2 over 6, leaving 5 raised to the power 6 there. So if, what is left here is what? 2 into the power x minus 1 is equal to what? 5 raised to the power 6. And of course, again, equal basis. You what? You equate powers. Powers. So if you're equating powers, I'm going to have 2 into what? X minus 1 is equals to what? 6. So open the bracket. 2x minus 2 is equals to 6. For that like terms, 2x is what? 6 plus 2. Then, of course, 2x is equals to what? 6 plus 2 is what? Is 8. Divide both sides by 2 over 2. 2 cancel 2. X is equal to 4. That is the simple answer to the question. All right, so we're going to quickly take some assignments. The first assignment I've given you is to be able to memorize the laws of indices without looking at your notes. It is very important. It is very important. Memorize it. After you have memorized it, this is the second assignment. Go to your OTD School JAMB app, look for questions under indices using the question search feature, and then answer questions on indices. And then thirdly, you can then answer these questions assignment. All right, so this assignment, you submit them. I want to see them. I want to see that you really did it. So once you are done with the assignments, snap what you have done and send it to this WhatsApp number 09121515246. The requirement for you to be able to submit this assignment and for me to be able to see it and judge you is for you to have the OTD School JAMB app activated and installed and activated on your phone. All right, so make sure you have the app, because I cannot be teaching students that are not serious. You get? So make sure you have the app, make sure you are studying and you are following us. All right, now let's go. You are going to have number 1, 10 raised to the power y times 5, 2y minus 2, then times 4, y minus 1 is equals to 1. So please find y. find y here. So number 2, 8 raised to power x over 2 is equal to 2 raised to power 3 over 8. Then 4 raised to power 3 over 4. Find x here. Find x. So the third question is 9 raised to power 2 x minus 1 all over 27 raised to power x plus 1 is equal to 1. Find x also. So please, this is the end of the class today. Please make sure you subscribe to this YouTube channel, and if you are not sharing these videos to your friends and loved ones and your colleagues in school or in the lectures, you are doing something very bad. It's very bad. Please share this video, click on the like button, give us a like, drop a comment, even though something as simple as this video was nice or I enjoyed the lesson. The teacher, even if it's a bad comment to even make us improve better, you can also drop it. So please drop good comment on the channel, drop good comment, and like and subscribe. Click on that notification bell symbol, click on it, so that once we release another video, you'll be among the very first people to see it. And of course, my name remains Owolabi Thank God, aka MC Owoblo. See you in the next class.